Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. In this video, we are talking about trigonometric functions and its inverse. We know that, let me underline few things. We know that if a function is one-to-one, inverse exists. So first of all, inverse only exists for a one-to-one function. Whether that one-to-one function is a linear function, whether it's a quadratic function, whether it's a cubic function, whether it's a trigonometric function, if it's one-to-one, inverse exists. When inverse exists, how can we draw the graph of its inverse? By reflecting the graph of the function in the line y is equals to x. We know this logic. We know that a point such as AB becomes BA when we reflect it in the line y is equals to x. Coordinates flip. This A becomes B and B becomes A comma B. A comma B becomes B comma A. That means the x coordinate becomes the y coordinate. The y coordinate becomes the x coordinate. Now we are talking about the three trigonometric functions, sine, cosine, and tangent, only have inverse functions if their domains are restricted. Why is this so? Because by default, a trigonometric function, whether we are talking about sine x, cosine x, and tangent x, yes, they all are function, but by default, all these functions are many-to-one functions. They are many-to-one functions because they fail the horizontal line test. A horizontal line test differentiates between a function, a one-to-one function versus many-to-one function. For example, let me draw a grid and let me draw the graph of y is equals to sine x. So if I draw y is equals to sine x, that is half of the graph, and that's the other half. We know that a value of 30 degrees will give me 0.5, and a value of 150 degrees will also give me 0.5. So two values of x, sine of 30 degrees is 0.5, and so sine of 150 degrees is also 0.5, and this is just for x between 0 and 360 degrees, and this keeps on going. So it fails the horizontal line test. It's cutting, it's intersecting at 2 points. So that is called failing horizontal line test. It's a many-to-one function. And the same goes for cosine, the same goes for sine, the same goes for tangent. So what they are saying is that if we restrict the domain, if we talk about a turning point to turning point, for example, from here to this turning point, yes, it's a one-to-one function. Maybe from 0 to 90 degrees, it's a one-to-one function. Maybe from 270 degrees to 360 degrees, this is a one-to-one function. So if we restrict the domain so that they are one-to-one function, the notation used for these inverse functions are arc sine, arc cos, and arc tan. We are more interested in these three ones, which is written as sine inverse, cosine inverse, and tan inverse. So that is the basic idea that we talk about when we talk about inverse function for a trigonometric function. Now let's look at this. First of all, this is y is equals to sine x. It's from 0 to 90, just like this. This is from 0 to 90. And this keeps on going. This is 0 to negative 90. That means negative 90 to 90. This is a one-to-one function. So 90 degrees is written as negative pi by 2. And pi by 2 is 90 degrees in the radian form. So we are writing in the radian form. And in the radian form, we know that 90 degrees is written as pi by 2. We know that 180 degrees is written as pi. Now, how have they drawn it? They have drawn this thing. The range is negative pi by 2 to pi by 2. the range of values of x, that is the domain. The range of values of y, which we simply call as the range, is between -1 and 1. And then when we reflect it, if I have this line, y is equals to x. So let me just give you the idea. If I have y is equals to x, this gets reflected. So this graph over here kind of becomes a graph like this. Got the idea? And that's how it is. Also notice the x values are now on the y-axis. The y values -1 and 1 are on the x-axis. So let me write it like this. If I write fx is equals to sine x and f inverse x is equals to sine inverse x, this is domain, this is range, this is domain, this is range. The domain is x lies between -π/2 and π/2. The range fx lies between -1 and +1. Now what happens is that domain becomes the range, range becomes the domain, flip-flop. So therefore, the domain is always written in terms of x, that is -1 and +1. And the range, since it's for inverse, it's written in f inverse x, that is -π/2 and π/2. That is how this thing is written. Now just acknowledge it on the WhatsApp if the graph of sine inverse is all good, all clear. So I'm just forwarding this message to other groups, and I hope it's all good, all clear. So that is the thing. And I'll share these images with you. Maybe there would be some images from yesterday, which needs to be shared also. I think that was about S1. Now I'm talking about S2, P1. Okay, now let's look at the graph of y is equals to cosine x. Now, when we talk about cosine x, let me draw the full graph. So if I draw cosine x, we will pick the selected part. So let me just draw over here. And when we talk about cosine x, we are talking about this portion like this. And let me just shift it a bit. And let me just draw this a little bit more. Okay, so now over here, this is -90. This is 0. This is 90. And this is 180. And this is 270 degrees. So that's one cycle. Now, it depends from where we want to pick it. So if we are picking it up from here, that is 0. And we are going all the way up till here, that is 180 degrees. Yes, this portion of the graph, this makes a 1-to-1 function. So I think that is the thing that they have picked up. Yes, it is. This is from 0 till pi. The y value is between -1 and +1. And again, it is reflected. So -1, +1 goes on the horizontal axis. It was first on the vertical axis. Now it's on the horizontal axis. 0 and pi, it was on the horizontal. It has gone up till to the vertical. So again, it's the same idea as this. We are talking about fx, that is cosine x. We are talking about f inverse x, that is cosine inverse x. And then we are talking about domain and range, domain and range. This is y is equals to fx. This is y is equals to f inverse x. So I think I pressed the wrong button or something. So now the domain is x is between 0 and pi. And this will become f inverse x lying between 0 and pi. The range is fx lying between -1 and +1. The domain of the inverse would be lying between -1 and +1. So domain becomes the range, range becomes the domain, that is the flip-flop, that is done. So all got all clear? Similarly, when we talk about tangent x, so let me draw the graph of tangent. So let me pick this grid over here. And now for tangent, let me draw two asymptotes. And let me draw two asymptotes. So 1, 2, 3, 4, 1, 2, 3, 4. Let me pick a green color. So the tangent one that goes like this, goes like this. Now let me label it properly. This is -π/2. This is π/2. This is y-axis. This is x-axis. At 45 degrees, that means π/4 radians, we have a value which is giving me 1. If I need a guideline in between, and at -π/4, I have this value, which is -1. So these two important pointers are there. And this time, instead of looking over there, let me first write y is equals to tangent x. This is y is equals to fx. So what is the domain? The domain is x between -π/2 and π/2, and it's not inclusive. And the range is fx is between -∞ and +∞. Because it's going till infinity, it's going till infinity, +∞, -∞. Now look at this. The two asymptotes are there, infinity and -∞. Now that is how this thing is drawn, tan inverse. These vertical asymptotes become horizontal asymptote. So let me first label that as the vertical asymptote. And now it has become horizontal asymptote. So let me label in blue color, green color. And it's going like this. And look at the shape of the graph. The graph is going like this. Now it got reflected in the line y is equals to x. So it's something like this. And it's stuck between these two values. So basically, it's stuck between these two lines. It's now stuck between these two lines. Again, domain becomes the range. Range becomes domain. So that is the basic idea about trigonometric functions and its inverse. So y is equals to fx, y is equals to f inverse x. It is necessary that it has to be a one-to-one function, because only one-to-one function will have an inverse, and the rest of the thing is the same as before. That is, it is reflection in the line y is equals to x. AB becomes BA, and domain of original becomes range of inverse, and vice versa. That means range of original becomes domain of inverse, and so on. So that is all from my side regarding this inverse function. Take care, everyone.